name is Daniel Tiller, and this is a presentation for UVA's SIS 2004 class, which is Data and Information Management, and my topic is Punchcard Databases. So during the 1890 census, the government needed a fast and efficient way to process its census information, so it contracted with an engineer named Herman Hollerith, who invented a tabulating machine that could automatically tally up census results if the information was encoded on punch cards. So let's take a look real quick at how the card reader of the Hollerith tabulating machine worked. So this is a simplified drawing, and this is a side view of the device. This is the this is a punch card, and this whole thing works kind of like a press. You pull down this rack of pins, which are spring-loaded, and where there's a hole, the pin is able to go down and into a reservoir of mercury, and completing an electric circuit which increments a counter. So if the presence of a hole indicated married, and the lack of a hole indicated unmarried, in this spot here, then we could use this counter to count up the total number of married people in the United States by running all of our cards through, well, I mean theoretically running all of our cards through this one machine. Hollerith founded a company which eventually became IBM, and let's fast forward to like early 1950s, where well, at which time IBM had expanded its product line and developed them, improved the products that it had. And so the question that I want to ask is, how is a Punchcard database in the early 1950s similar to a modern database in Access or MySQL? So what did a database look like? Well, it looked like a box or boxes of punch cards, and a table looked like a stack of punch cards, and a single tuple of a table was represented by a single punch card. So I want to show how information is stored on a punch card real quick. Okay, so this is a standard 80-column punch card. It has 80 columns, and it has 12 rows. 10 of these rows are labeled 0 through 9, and the other 2 are unlabeled, and we'll call them X and Y. So each column is used to store a single character. So if we want to store a numerical character, we punch one of these rows 0 through 9. If we want to store an alphabetical character, then we punch one of the positions X, Y, or 0 in conjunction with a number 1 through 9. And that allows us to represent 3 times 9, 27 different possible characters. So we have all the letters of the alphabet plus maybe a period that we can represent. So if we were a bank, we might be interested in having a stack of punch cards that store the information on all of the people who did business with our bank, along with information like their balance and things like that. So we might use the first 3 columns to represent a unique customer ID for each customer. We might use, I don't know, maybe these columns to represent the name of the customer. And maybe we'd use these columns to represent the address, and use these columns to store the current balance of the customer. So people enter data on these punch cards. They punch the punch cards using a special card punch. And once we have the data on the punch card, there are quite a few useful things we can do with it that we want to do with data in a modern database as well. We can sort the data. So for example, if we wanted to sort the attribute customer ID in this layout, we would sort first by column 3, then by column 2, then by column 1, using a sorting machine. And if we want to perform calculations on the data, we can do that as well using a machine called a tabulator. And the tabulator has a control panel that can be wired up so that the machine can perform particular calculations on data. Maybe end-of-month accounting, where it sums and subtracts to create new balances for customers. We can merge tables using a machine called a collator that has multiple hoppers. We can drop stacks of cards in, and the cards can be joined, the stacks can be merged together based on a shared attribute. Punch card machines enable the government to ask more questions on the census. They enabled companies to manage large amounts of data like they've never been able to do before, and they ushered in the age of databases and data processing. Thanks for watching.